Hello folks, so in this video I'm going to talk about how to merge or join two data frames just like we join tables in SQL or SQL programming language. So essentially I'm going to show you the different ways to merge Pandas data frame. So sometimes there is a necessity to combine data from two data sources or data frames from a data wrangling perspective or as a pre-processing step. So data scientists or data analysts primarily use these methods to ensure that they are getting a detailed view of different features or attributes or column as a matter of fact at one place. All right. So this is Nitin, who is determined to democratize the artificial intelligence, big data, Hadoop, and cloud computing to the world. And with this aim, I will be creating the associated content and going to publish periodically and made it available for you. So you can subscribe to my channel to get the latest updates regarding hottest technologies of 21st century. So here is my Jupyter notebook, and so what I'm trying to do is here let me import the pandas library first, which will actually help us to create a data frame as well as perform any operation on a data frame. So let me import that library. It's very important library, in fact. Pandas SPD. Okay, let's run this cell, and then let me import three CSV files to create three separate data frames. Okay, so the first one is root data 1. Okay, and I will be reading this CSV file, so read.csv, and the name of the data frame and the name of the file is same. Yeah, I kept it same for the sense of brevity. Third one, let me print out. Let me see the content of this data frame. Let me run it. So you can see that there is a root ID, and then there is a source, and then there is a destination. So source is the place from where the bus or any other mode of a vehicle starts, and destination is where it reaches. And with each combination there is a root ID associated. Okay, this is our first data frame. The second data frame is similar but with different cities or the source and destination IDs. Source and destination as well as route IDs, in fact. So let me run this as well. So this is the second data frame. All right, the third data frame is bus code data. Okay, all right, so let me see the content of this one as well. pd.read_csv, and then the name of the data frame file, in fact the name of the CSV file. All right, so let me print this as well. So you can see the third data frame has actually 15 rows. There is a route ID, there is a bus code, and then there is a bus service name, which is yellow service, yellow bus, orange bus, etc. Right, so this was the third data frame. Let me create few cells here. So first up in the list is full outer join, which generates a new data set by merging two different data sets such that it contains, or both the data set contains, when we merge these two data sets, it contains matching records from both the data sets wherever available, and if in case there are no matches, then the missing side will be depicted by null. Okay, so the first one is full outer join. Okay, and we'll type pd.merge and then the name of the data frames, which is root data _1 comma root data 2, and then on which particular ID we want to join these two data set. It's route ID. So on equals to route underscore ID, and what type of join we want to do, it's outer join. So how parameter should be depicted by outer, because we want to do outer join here, so that's why how parameter should have outer here. Okay, so let me run this. So now you can see that we have done outer join. So basically, as I told you, outer join, right outer join, what it does, it combines the data from both the data frames, that is from this data frame as well as this data frame, right? And wherever there are matching records from those data sets, it will show those values. Okay, so you can see that the matching values are here. The root ID 567 are matching IDs, so it is showing those. Okay, and in case there are no matching data, so in this case there is no matching data for these values, right? And in this case for these values. Okay, so row number or the root ID number 1, 2, 3, 4 doesn't have matching records for the source and Y, and source Y and destination Y. So basically, if you see these two data frames here, you can see that the root ID, the matching root ID are 567. If we want to match the root ID 1, 2, 3, and 4, we won't be able to match because this data set doesn't have 1, 2, 3, 4 root ID. And similarly, the first data set doesn't have root ID 8, 9, 10, and 11. So that's why the non-matching records are depicted by NaN or not a number or null values for these type of records, right? For these records as well as these records, because we don't have any matching records for these, right? So this was full outer join. Second one in the list is right outer join, which takes all the records from data frame on the right side with all the matching records from data frame on the left side. Okay, so in this case also, if there are no matching records, then the values will be depicted by null or NaN values on the left side. Okay, so let me copy paste this command. Okay, right outer join. Okay, and here I will mention right. Okay, instead of outer I will mention right. So when I print this, you can see that it took all the records from the data frame on the right side. Okay, so from this data frame it took all the records. Okay, but and in fact the matching records as well, so both matching as well as non-matching records from the right data frame. Okay, and wherever there are no matching records, then the values are depicted by null or NaN. Okay, so that it means, so right outer join is including all the records from the right side data frame, okay, whether it is matching or non-matching, and including and if there are no matching records, then showing the values as NaN or null. Okay, so that is right outer join. Similarly for left outer join, so left outer join. Okay, so instead of how equals to right, we will mention left. Okay, so what it will do is in the case of left outer join, it will take all the records from the data frame on the left hand side with all the matching records from the right side. Okay, so in this case also, if there are no matching records, then the values will be depicted by null or NaN values. Let's print it, and you can see that it has listed out all the records from the left data frame, which is this one. So whether the records are matching or non-matching, it has listed out all the records. But on the right hand side for this particular data frame, if there are no matching records, then it is shown by NaN or null values. Okay, so we know that only 5, 6 and 7 root ID numbers were matching, so it is showing the matching records. And from the right hand side, so matching records and all the records, basically in a nutshell you can see that all the records, whether it is matching or non-matching, from the left data frame, and only matching records from right data frame, and wherever there is no matching record, the values are shown by NaN or null. So it's just a reciprocal, just a vice versa of what do we have in right join. Okay, right. So the fourth one in the list is the inner join, which creates output in the form of having records matched from both the data frames. That is, the set of records that matches in both the data frames on left, that is on the left hand side, and the data frame on the right hand side. So it just prints the matching records. Okay, so we'll print, so inner join. Okay, and in this case we'll mention inner. Okay, so it will print only the matching record, which ideally should be root number 5, 6 and 7. So it should output 5, 6 and 7, and you can see that it has printed only the matching records. The inner join has printed only matching records. So if you are aware of the concepts, these join concepts in SQL or SQL, you would be able to figure out easily what I'm trying to say here. Okay, otherwise you can I have already explained these things previously, the other join type of joins, so you would be having a fair amount of idea now how much or how these different type of joins differ from each other. Okay, so now you have that knowledge. Okay, if in case you are not aware of SQL programming language concepts of join. Okay, now you could also suffix column names when doing these kind of merge or join operations. How do we do it? Suffixing column names. Okay, so how can we do it? We will add one more parameter here. Okay, and the name of the parameter is suffixes. Okay, and we'll give the name of the suffixes. So for the left data frame, we'll give the name as underscore left df, and for the right data frame we will mention the name as right df. So you will see these suffix values included in the column names of the data, the new data frame. Okay, so let me run this, and now you can see that earlier these were suffixes by x and y, the random values, random characters, right? X source x, destination x, source y, destination y. But now here you can see for the left data frame, it has suffixed the column name as left df, and for the right data frame as right df. So that way we can suffix the column names to basically figure out which data frame is which one, which is the right data frame, which is the left data frame. Okay, so let's move on to another one, another concept, wherein the fifth, or I would say the fifth concept is the one in which the list. So basically what I'm trying to say here is, so we want to merge the data frames on the basis of indexes, rather than based on the column value. So here you can see that I basically so here we have root ID as common column. So if you see these two data frames, I have root ID in data frame 1 and then the data frame 2 also. So basically these two data frames has a common primary key, which is root ID. Okay, so generally whenever we do these kind of join operations, even in SQL, we join on the basis of a particular column or the primary key. Okay, so this is the primary key, but instead of joining on the basis of this primary key, we can also join on the basis of these index values, which are these row numbers 0 1 2 3 4 5 6 7 0 1 2 3 4 5 6. Okay, so these row numbers depicts the indexes, so we can join on the basis of these indexes also. So how do we join on the basis of indexes? I'll show you here. Okay, so again, join on the basis of indexes. Alright, so only change here is we will change the parameters here. Okay, so the parameters we will define is the right index and the left index. So right index equals to true, so enable this right index, as well as left index value as also true. Okay, so when we do this, so we have enabled the right index as true and left index also as true. So we can see that it has now joined on the basis of the indexes. Okay, so you can see that all the the values are listed here. So for root ID 1 2 3 4 5 6, how many records were there? So there were 7 records, 7 root. So here we had 1 2 3 4 5 6 7 root ID, and here the root ID started from 5. So 5 6 7 8 9 10 11. Okay, so it has listed out all the records. So 1 2 3 4 5 6 7, the first data frame, these were the values of. So anything depicted by suffix x is the data frame 1 values, and that is root data 1, and anything depicted or suffixed by y is the second data frame values, which is route data 2. Okay, so you can see these values. So this is the way we join using indexes. Okay, so next we I just wanted to tell you that we could also join two data frames along columns by using concat operation. Okay, so we can use the concat method to join two data frames. And how can we do it? It's just simple. So instead of pd.merge, we will type pd.concat. Okay, and then the name of the data frames we want to join. So here root data 1, root data 2 are two data frames which we want to join, and we need to enclose them in solid brackets. Okay, and the next parameter is axis. So here we'll mention the axis equals to 1. So axis equals to 1 depicts that we want to join on the basis of columns. Okay, so we want to see the columns joined. Okay, so basically what I'm trying to say here is we are joining two data frames along columns. So axis equals to 1 depicts that we are joining along columns. So you can see that these are joined now. So this root ID, source, destination, this is the first data frame, which is root data 1, and this second set or the root data 2 is depicted by these values: root ID, source, destination. So we have joined along column. Now we could also join two data frames along rows as well by using concat operation. Okay, so here we joined the two data frames using concat operations along columns using axis equals to 1, and here if we want to join on the basis or along the rows, basically join along rows, then we can do it by using concat operation or method as well. The only change we need to make here is we don't need to mention axis here. Okay, so without mentioning the axis, we can join the rows along, or we can join the two data frames along rows. Now let's press shift enter, and you can see that the two data frames got joined along rows. So first data frames were having root ID till 7. Okay, till this point, this is the first data frame, root data 2, and the second data frame values were starting from root ID 5. So 5, 6, 7, 8, 9, 10. So these are this is kind of a union which we have done, but essentially you know, all the rows were included. Okay, here. So what I was telling you was that the first data frame was having values starting from 1 till 7 root ID, and in the second data frame the root ID starts from 5 and ends till 11, and this is kind of a union we have done here. So along the rows, so 1 to 7 root ID, and then the second data frame has value 5 to 11. So kind of a union we have done here, and this is the way we basically join two data frames along rows. Okay, so we had third data frame as well here. So let me try to join that one as well to see how our output will look like. So I will join the above data frame, which was bus code data, with with this. Okay, so let me store the value of this data frame in a new data frame called df. Okay, and then I will join this data frame, new data frame, with the another third data frame which we created earlier, which was bus code data. Okay, so let me do that. Let me run this operation, and we have values of this data frame as this, and then I will type pd.merge. okay, and then the new data frame, which was df, so this data frame, df data frame, and the third data frame which we created here, which was bus code data. Okay, so this data frame, df, and on which particular column we want to join these, on root ID. So earlier I showed you how could we join the data using the indexes, and here I'm showing you how can we join the data frames, two data frames, on the basis of a primary key or a column value, which is root ID. This is the primary key here in our case. Let me run this, and then you can see that it has joined all the. So we have values from this data frame, which is root ID source destination. So root ID source destination, and from the second data frame, which was bus code data, we have bus code as well as bus service. Okay, so here we had bus code and bus service, so we have these two columns as well included as a part of a join operation. Okay, so this is the way we join or merge the two data set on the basis of a primary key or a column. Okay, so folks, this is it for this video. To conclude, we learned how can we merge two data frames in various ways, whether it is left, right, or full outer join, as well as inner join, in fact, just like we have these in SQL programming language. So today's question is, do you think that merging or joining data frames using this method is simpler than SQL language join operation? Please comment in the comment section given below. I would love to hear from you. And if you're watching this video and you're not already a subscriber to our channel, consider clicking that little subscribe button In case you have already subscribed, then click on bell icon to receive the notifications whenever I will release a new video. So thanks for hanging out with me, guys. I will be covering next topic in the upcoming videos, so keep on watching. Thank you.